Hi all, welcome to my channel. This is the ongoing series of Java concurrency in a new way. So till now we have discussed many things like creating a thread, Java logs, synchronization, volatile keyboard, atomic integer, and lot more concepts. So in this video and the next video, we're going to discuss about some of the important two data structures which provides a thread safety over the existing traditional data structures. Like for example, a HashMap alternate is basically concurrent HashMap. And similarly for array list, we have copy on array list. So in this video, we're going to discuss about concurrent HashMap. If you basically miss those videos of previous videos, I put the link in description, complete playlist. You can please go and watch. These are the basically foundations for any Java concurrency concepts to understand. Now, without any delay, let's go into concurrent HashMap. Once we're done with the theory part, we'll also implement our own concurrent HashMap in a most simple version like. So, and also talk about some of the key features of existing concurrent HashMap, how it's providing the thread safe with very less contention. So, what is concurrent HashMap, right? Concurrent HashMap is a thread safe variant of HashMap in Java. So, is it only concurrent HashMap the thread safe of HashMap, or basically HashMap has other variants also? Is any other variants also providing the thread safe feature? Yeah, so there are like three thread safe features are there in a HashMap. One is basically hash table, second one is basically synchronized map, and third one is basically concurrent HashMap. Among three, concurrent HashMap is the most optimized version of thread safe feature of HashMap. So what is this hash table and synchronized map, right? So hash table also a legacy. It's a basically implemented at the beginning of Java framework. It's a legacy thread safe implementation of a map that basically uses a single lock. So for example, for the whole map. So while what is exactly locking, right? Locking basically blocking all the threads parallel reading. So you can only perform sequential reading, like if after completion of a thread, then only the other thread will basically reads the data, like whatever mentioned the blocking state. So what happened with the hash table? The hash table, it's a thread safe feature, but what they exactly do, they have basically applied the locking on the whole map. So which means like when it comes to high concurrent operations, right, the hash table performs very poorly, like. So and also it has a significant contention because of complete locking of the whole map itself. So but this is a thread safe one, like. So we have another one called synchronized map. It's also basically wrapping the complete synchronization on top of the whole map itself, like, and it's also using a single lock which is also similar to hash table, like. So these two basically a thread safe variation of HashMap, but the main drawback of these two is basically these are basically will not basically scale in large applications. We require say very high concurrent applications. So these are basically poor concurrency feature and also a very high contention. That's where we developed a feature called concurrent HashMap. It's one of its kind of a data structure of a HashMap which provides a high concurrency and very less contention. Let's see how. So it's provided better concurrency by allowing multiple reads and certain number of writes. If you understand this exact statement, right, it will provide a concurrency allowing a multiple reads. For a multiple reads, you can access the data simultaneously, and for a writes, you can still access the data simultaneously, but some extent, like. So that's the cache word. How they basically allowing the writes concurrently for a certain number. That number is important. Like we'll see internally how they will do, and so there are like two ways basically concurrent HashMap achieves this one. One is basically through segmentation. So in Java 7 or earlier. So what exactly they have implemented this concurrent HashMap? They have a HashMap. For example, thinking the HashMap is the key value pair, right? So they have divided the HashMap into multiple segments. So for example, this particular segment, for example, this particular bucket, they have divided the HashMap. So HashMap itself is a single bucket. So now they have divided the HashMap into multiple buckets. So now when performing write operation, right, you need to perform the locking only on the particular bucket where the data where it's supposed to be write. So rest remaining buckets, you no need to perform locking, you can still access the data concurrently, like multiple threads can still access. That is the benefit they have added for the concurrent hash map. So involving dividing the map into segments, each of which is essentially a separate hash table with its own locking. Only write operations that affect the segment acquire a lock on that segment only, allowing reads to access the map concurrently and writes to process with a minimal contention. So in future, in Java 8, in the later versions also, in the most recent Java also, they have basically implemented even more better approaches than segmentation, which is nothing but a node-based structure by using a synchronized blocks with compare and sweep operations. So which will basically improve the scalability and minimizes the lock contention. So these are the two approaches they have taken, one with the through segments in the Java 7 or earlier. Once they have from Java 8 onwards, they have moved to the node-based structure with a compare and sweep operation. Like, so we'll see a simple version of HashMap, concurrent HashMap in both the segmentation way and also CS operations way. Now let's code segmentation HashMap. So here I am giving a segmentation HashMap example. Okay, so I created a Java class called segmentation HashMap example. As I said, there are basically dividing the data into multiple segments, right? So first we required a inner class, let's say segment, private static class, let's say we give a name as segment. So in each segment, we basically have a hash map, right? Let's construct in a more generic way, where key and value dynamic one, so it will be scalable, right? Map. And for this particular segment only, whenever you're performing a write operation, you have to give the lock on the writes, right? That's why you have to create the reentrant lock. So private reentrant lock equals to new reentrant lock. Now let's insert the data. So public void put key comma value. So while inserting a data, you basically keep the try catch block and you're basically acquiring the lock while updating the data. Lock dot you're performing a lock operation and you're basically keeping the value into the data, like map dot put key comma value. Finally, you are basically unlocking lock dot unlock. So here it is possible that map might return the what exactly map will return. Map will basically return the v object, right? So we can just keep the v only value and we can just mention the return. We are basically simulating the exact map, right? So public get, so get a key, right? You're passing a key and it will return the value. So get you're passing a key, return map dot get off. Here you don't require any locking, right? You can parallelly access as many times as you want. So this is how you have basically created a segment. Now our segment is ready. We can just create a so the segmentation hash map, what that what do you call, like segmentation hash map basically create a multiple such segments, right? Basically multiple segments. So we can create a segmentation array itself. Private segment let's pass k comma v here, segment k comma v, segments equals to this is the array, right? Okay, and we can have private int segmentation count. How many segments you want, like. So this is not a true what do you call it, this is not a true version of segmentation hash map. This is basically I'm simulating a very simple version. So in the original one we have a lot more complexities will be there. Now let's create a constructor. I think this is not required for the constructor. So here whatever segment count we'll get, we'll initialize this dot segment count, and here we'll basically initialize that value, like total number of segments. Yeah, I think yeah. So for I'll basically create those many segments, right? For int I equals to 0, I less than segmentation count I plus plus. So segments dot I equals to new segments. So I created those many segments here. Now our segmentation hash map is ready. Now let's perform these put and get calls. This is the important what are the three main operations will be required here. One is basically put, get, and also hash function, like which will basically defines to which segment it has to be moved. It has to be inserted. Private int hash return key dot hash code percentage segmentation count. So this will help us to define to which segment it will basically fall, this particular key will be fall. Now what you can do, you can basically build a public methods, public put k key comma v value, yeah, v value. Now what you can do, first you need to compute the segment. First you need to call this hash method int segmentation index equals to hash of key. You will get the segmentation key. Once you get the segmentation key, now you need to basically get that particular map segments of segmentation index. Segment of segmentation index. Once you get the, you have to basically put, right? So I think let's yeah, you basically put the value just key comma value. Similarly, let's perform the get operation. Public we get k key, right? So int well, let's fetch the segmentation index hash of key. So once you fetch the segmentation index, we can simply return the segmentation segments dot segmentation index dot get of key. And so this is the basic simple version of segmentation based hash map, right? It's very simple. Like we have divided the multiple segments. In real, it might be very complex one. Like it's a very simple feature I'm simulating here, implementing the own segmentation hash map. So in the main method, you can simply create a segmentation example seg map equals to new segmentation map. Here you can provide, okay, I want basically maybe 10 segments. Now segmentation map dot put off, for example 1, 2. So your key is basically 1 and value is basically hello. and similarly segmentation map dot put of let's say 15 comma world. You can perform like it doesn't simply s dot out of println segmentation map dot get of 1. Let's see whether your hash map is working fine or not, or any issues are there, like get of 15. Yeah, we got the answer right. So this is the basically simple version of segmentation hash map with the help of dividing the hash map into multiple segments and give the exclusive lock while performing write operations to the put method, and for get method you don't require any operations. So now compute the hash code. It basically defines the which segmentation it needs to go. Once you get the segmentation index, you can simply perform the put and get, you can delegate the operation of put and get operations to the particular segment. So this is how simple segmentation hash map will work. So now let's see what is the performance benefits, right? By reducing lock contention, we are basically locking only on the particular segment only, not on the full hash map, right? Like how the traditional hash table and synchronized map. So the map allows higher concurrency, obviously, especially beneficial in multi-threaded scenarios where multiple threads are accessing and mutating the map concurrently. Like, so scalability, it scales well as the number of threads increases because different threads can operate on different segments simultaneously without blocking each other. So while performing a read operation, it might possible that while readings can always be in different segments, writings can be also different segments, right? So that's where it's basically working. It has provided a less contention compared to the traditional hash map and synchronizer map, and also provides a high concurrency itself. Now let's code the node-based compare and swap. This is a little bit complex one. I'll code in a most simpler manner. Let's see how far we can go. Okay, now let's create a node-based example, right? Now let's have a node-based CS hash map example. Okay. So now what exactly this node-based CS map example contains, right? So first it will have this concurrent array. So first it basically stores the data in a linked list format. So basically whenever a data is presented, right? So it will basically form a linked list across in a atomic reference array, like in a concurrent package. So first basically let's say in a traditional singly linked list, and also for each array index, for each node index, we require a locking on that node. So basically we are performing indexing, we are performing a locking on the particular segmentation only. So here we require two things are there. One is basically atomic reference array to perform this concurrent, to perform this to divide the segments into a multiple, to divide the maps into multiple tables, and performing and required a segmentation lock array, which will basically keep track the locks of the each table. Yeah, I think these two will be required. So before that, let's define a node. Private class node k comma v. I'm writing quickly. So we required a hash function. So next we required int k key function, and next we required a v value function, and then we required for in general linked list, right? What we require to store the next address, right? So for that we have this again next address node k comma v next. So now let's create a quickly constructor generator. Okay. Okay. Now let's create. I have created constructor. Now this part is done. Now let's create a atomic reference array with this node private atomic reference array. If you see, this is from concurrent atomic package. Private atomic reference array and pass this node k comma v. Okay, let's keep it as this is also generic node k comma v. Let's name it as a table now for now, table, and let's have a segmentation logs, right? Like all the logs required for each table, right? So each part of the table. So we require a segment, require a reentrant log. Log. Let's define this as the array segment. Segment array, segment logs, and also let's have a default capacity table. Similarly, how we design for segmentation hash map, right? Let's have a 10, 16 maybe. So here we'll see how to basically create a hash function based on that. So private integer default capacity CAPA default capacity equals to, let's have 16. Now let's create a constructor, public node based CSS example. Here this dot table, right? This dot table equals to new. Let's initialize this one with the initial value 16, default capacity, and let's initialize this segmentation logs itself equal to with the default capacity. New reentrant logs, sorry, this is array, right? New reentrant logs of default capacity. Once you're done, let's do this for loop. For int I equals to 0, I less than default capacity, I plus plus. So this dot segment logs, let's initialize each one. This dot segment logs of I equals to new segment logs. Okay, new reentrant log. Cool. Now let's define our put method and get call, right? So public value put k key comma v value so, and we have public value, right, for get call v value, sorry, we are passing key, so key. Now let's define a hash function. So int hash value equals to, let's define here separately private int hash equals to. We can also define hash function in a different way, or else whatever mentioned in the segmentation hash map. So how can we define here? Key equals to, let's declare a h if okay, return if key equals to null, that should be first index, assume. How concurrent hash works like. So return 0, our hash value is basically 0. Now okay, now basically otherwise perform a hash code, key dot hash code, assign this one, and perform this OR operation up to 16, right? We have default capacity 16, so h 16 left binary operation and 16. Now we can basically perform this hash of key. Now let's define a we need to get the index, right, which table it has to be inserted, so that we need to acquire the lock on that particular table index, right? So int index equals to table dot length -1, and this will basically get the total length of the table, and we can restrict that one to the hash value, which will always be in the which will always false in between 1 to 16. So now let's perform a get operation. For that, now let's fetch the lock of the particular table, right? Particular subtable. Reentrant lock equals to reentrant what segmentation logs. Segmentation logs of index. So now perform the insertion operation. So we are basically keeping the lock. We are performing the locking on the particular index only, particular index object only. Reentrant log dot lock. Now how the traditional linked list will work, right? K comma value node equals to table. Obviously this will basically called as a first node. Table dot get of index value. So how we generally do, we basically compare. If it is first one is a null, we'll create an object insert. Otherwise we'll put it in a next value, right? So so here we'll do one thing. If the value is already presented, we'll put that value, we'll put the existing value in the next value, and the current value is the first value, like inside of the beginning value kind of. So if first equals to null, first we need to, I think it will iterate. So for first not equals to null, and then before that we have this condition as well. Next, right? Yeah, e dot next. Okay, e equals to e dot next. I think while loop is better. Let's say anyway, fine. Okay, once we get anything from inside, node dot k comma v node equals to new node of first is basically what is the hash value, right? Hash value, key value, and first value. We are saying inside at the beginning. So first value, and what we are doing, we are setting in the table. So table dot set of index comma node. Yeah, cool. So now let's iterate this one. Here we basically checking if the value is already presented. If the key is already presented, right? We generally need to do we need to update the value. So that is the use of this for loop. So here let's check the key is already presented or not. For that, e dot key equals to key, right? And e dot hash equals to hash value. E dot key equals to hash, and okay, e dot key equals to key, and e dot hash equals to key. Now what we should do, e dot value equals to new value, and return the old value. For example, old value, sorry, value old value, and okay, old value equals to e dot value, return old value. I think that's how HashMap will work. It will return the old value, like okay, yeah, cool. Yeah, I think this is correct only, right? So and it will return the null for the first insertion. So in the finally block, let's unlock lock segmentation, reentrant lock, reentrant lock dot unlock. Cool. So this is how we got this put method, and now let's get method. It's a simple one. Same do this computation in HashMap int index. So once we get this computation, we can simply perform table dot get of index otherwise return the null. Yeah, so this is the one kind of operation, one other variant of implementing a thread safe one with the help of atomic reference array and reentrant locks array. Like, so this will basically called as node based compare and swap example of HashMap. So this is also, while testing also it's a traditional one. I won't go into very in depth of testing. You guys can go and text this one how it will basically work. Like as concurrent, you can perform this in a concurrent environment also, like create multiple threads and keep on adding the data. So it will basically perform this one, like it will work. So yeah, I think I think you hope you understand what is basically concurrent hash map. So yeah, before that we can also just see what basically internal present inside the concurrent hash map. Let's import this package here, concurrent hash map, right? So let's go inside concurrent hash map just to see what exactly it's presented. So the most important basically put method, right? Put. So if you see, it's basically putting the value here. It's almost getting this hash value and performing this node based value, right? What I just demoed you. So yeah, this is basically somewhat a complex one. So I have given you the basic implementation of HashMap because there is a lot more things to deal with the node based structure. So but the idea is same, like this is the data structure inside using concurrent HashMap, the node based one. Like, so it has a multiple if else conditions and similarly for get also it will be almost similar only. Okay, 1 second. Yeah, there's lot of checking is there. So maybe get off, maybe key. Yeah, this one, right? Yeah, this is also, we have basically get the hash code and performing this node operation, and we're also performing this for loop, right? The how we just exactly do here, right? But we are generally doing a for loop, so they have done in the while loop. So this is the most basic implementation of the existing scalable concurrent hash map. So just go